Hello and a warm welcome to the next project. In this oncoming videos and from this video, we will be performing a simulation that will make us understand the procedure for performing a simulation with different fluids or different materials of fluid. Generally, most of the simulations people assume that we can perform with respect to the airflow simulations, but CFD is not restricted to airflow. It is rather having a very wide scope of possibilities to simulate. You can just consider any form of fluid that is moving on a surface. That kind of simulation may be predicted or performed in the CFD solvers. So in order to explain you the procedure for changing the material and assigning to the domain and performing that kind of simulations, we will be dealing with a simple project in this workshop or in this project work. And what I will be doing is I will be creating a simple circular cross-sectional pipe of some random length, and we will be performing a fluid flow simulation of different materials. For example, we will consider water or any other oils. Okay, and the main objective is to understand the procedure to assign that particular material and perform the simulation. Clear? So this is a kind of conceptual study where hence I will not be having any comparison of results with some experimental or some reference data, but rather we are just trying to understand the procedure for changing the materials in ANSYS Fluent. Clear? And for performing the simulations, I have two options. The first one is to perform a 2D simulation, and in the second case we can perform a 3D simulation. All right, so I plan to perform the simulation in a 3D fashion, okay, because the next objective, the next task or the next project which will be continued after this will be something with respect to discrete particle or discrete phase modeling, right? So there I will be showing you some different things over there. So for that I need a 3D simulation case, and in order to get a 3D simulation case ready, this project will be very helpful for us. Clear? That is my plan. And it is not necessary to always go with 3D simulations, because 3D simulations are computationally expensive. It is rather a choice of the user and the respected objective considered. And if it is possible to simplify the case into 2D form, that is really well and good, because you can immensely improve the quality of simulation in that case because of the mesh sizing, and you may attain almost real or near to good results. Clear? So let us just proceed. The first and foremost task is to click on geometry, or right click on the geometry module, and you will be having something called as properties. From the properties I will be checking the analysis type, that is select it as 3D, because I am performing a 3D simulation. If you're performing a 2D simulation, you rather have to choose it 2D. And I'll just close this one. Now the first and foremost job according to the modules of ANSYS Workbench is to create a geometry. Now one has different options. One may go with a CAD software to create the model, okay, such as Creo Parametric or CATIA or SolidWorks or any CAD software which you are comfortable with. The next option is to utilize the inbuilt design modules of ANSYS, that is SpaceClaim and Design Modeler. Now I really thought, let me just explain you all the procedures. Okay, yes, it takes a lot of time. You'll be having more videos on that, but I just want to share the different options what we have or what one may choose from, right? So if you're comfortable with any of these, you can just choose that, and you can just skip the next video and go to the meshing videos. All right, so the first and the foremost simulation will be, the first and the foremost modeling will be performed with SpaceClaim geometry. So I'll just right click on that and click on SpaceClaim geometry, and you can see that on the left bottom side or on the bottom left side we have a message that is saying us that the SpaceClaim module is being started. Now generally the SpaceClaim takes a lot of time to open. It depends on the system configuration and speed of your complete desktop what you have with you, and you just have to wait for a while until it opens. Now that we have this SpaceClaim ready with us, and to be honest, I really generally prefer some CAD software for modeling 3D domains, okay, when I'm performing any simulation, because I don't really like the options which are available in the design modules of ANSYS. But nevertheless, we can try to just know the options which are available, and we can just consider and perform certain simple basic models as well, so that we will be having some hands-on experience with this, right? And I was just sharing my preference that I will be selecting some CAD software such as Parametric for modeling any form of domain what we have, especially with respect to 3D, and also in some cases for 2D simulations. Now the first and foremost task in SpaceClaim is to set up your plane, okay. Set up in the sense we need to select the plane on which we need to create a some feature. Clear? Now if you imagine a pipe, it is cylindrical in shape, it is having a circular cross section. Now as per the modeling procedures, if you want to create something similar to cylinder or something similar to pipe, the first and foremost task as per the CAD modeling procedures is to create a circle, okay. And after creating the circle, we need to extrude it or pull it, okay. So that is what is the first step, and that is what I have to do over here as well, right, in the SpaceClaim. And for that, the first and foremost thing is I need to decide what or which plane do I need to work on. Clear? Now we have different planes. For example, we have XY, YZ and XZ planes. Now it depends on your domain, it depends on your intention of the planned direction of the flow, okay. For example, if your flow is in X direction, then your pipe must be parallel to this X direction, it must be oriented in that way. Clear? Or if your pipe is standing up, clear, then it will be parallel to Y axis. Clear? So it depends on the orientations and every aspect of the domain, like in what orientation is your pipe fitted in the system, right? So all those things you have to consider and try to orient in that way, so that you can just try to replicate the real physics of the flow or real physics of the system what you're planning to simulate. Now I will be considering that the direction of flow is in X direction, so the orientation will be like the length of the pipe is parallel to X axis. I believe you're catching it, right? And if you're not understanding, never mind, after completing of the model you'll be understanding what I'm meaning to say. And if I'm wanting the flow to be in X direction, so I must be having a circle in the YZ plane, isn't it? Because I have to create a circle in YZ plane and just pull it up in this direction, so that I will be creating a cylinder or cylindrical pipe. Now what I will be doing is, we have these graphic icons over here. I will be selecting the second one, which is called as select new sketch plane. I will be selecting that and hovering my cursor on the YZ plane. After that, I'll just press the left click and leave the see that the plane is in this form, or in the plane of YZ. Clear? And this is the sketching plane. On this plane you have to create the sketch and perform any editing options. So the first and foremost thing is, let me align the plane to normal. So I will be selecting Z axis. You can see it is straight line. The plane is from the side view. So I'll be selecting the X axis over here, and the plane is now clearly visible, normal to the screen. Now I will be selecting the circle over here and keeping the origin as the base point, and I will be just moving my cursor from left to the right. When I'm just moving from left to the right, you can see that the respective text field is also changing, that is representing its diameter, because there is a symbol of diameter being associated with the text, and that is in the prefix. Clear? So whatever diameter you want, you can directly enter over there. For example, I want a diameter of 100 millimeters. I will just type 100 and press enter. Now you can see that I have a circle of 100 mm diameter. Now you can just select this cursor over here and you are into the default mode. Now you can just click the middle click and you can just move your screen to see the cylinder or circle being created. Now I want the circle to be pulled in this direction or extruded in this direction. So what I'll be doing is, in order to pan, just hold the control, middle click and move to the left and right. Move your mouse left and right. Now I need to pull it on the right direction. So what I will be doing is, first and foremost thing is I need to change the ribbon over here from sketching to design over here. Now in design mode, you're having different options. Clear? So what I will be using is, I will be using the pull direction, right? And I will be selecting it at first, and after turning it on, you can see a message over here, select and drag a face to offset it, right? So I will be selecting this face at first. Face is selected. Now I'll be selecting the X, what do you call, axis, and I can just drag it left and right. Now you can see a text field being presented over here again. Now that will help me to enter some specific value. Now holding the left click, I will be entering 1000 over here and press enter. You can see automatically it got adjusted, right? And if you want some other length, you can just type 500. It will get adjusted accordingly, right? So this is what are we doing over here. We are extruding it, we are offsetting it, or we are pulling it. So different terminologies can be used, but the main intention is to create a three-dimensional pipe with a circle. Now when we are satisfied with the dimensions, for example, if I wanted to be something around 1.5 meter, that is 1500 millimeters, I can just type it as respected value. Clear? And after that I'll just press enter, or I'll just click on site. You can see that select this mode. Now we are into the normal mode over here, and there it is. We have completed the modeling of this pipe in the SpaceClaim. Now after that we can simply close it, and we will be back to the project window, and this is a SpaceClaim model. So if you're comfortable with it, you can proceed to the meshing video directly, or if you want to see and learn the option for creating the same geometry in the design modeler, then you can just open the oncoming video, and you can just see the modeling and design modeler, right? So let us just meet up in the next video.